Hey guys, so today we're going to look at experimental probability and making predictions. And yesterday we looked at theoretical probability. So let's go over a couple of vocabulary terms first. So some new terms: experiment, trial, outcome, and event. It says an activity involving chance, such as rolling a cube, is called an experiment. Each repetition or observation of an experiment is a trial, and each result is an outcome. A set of one or more outcomes is an event. For example, rolling a 5, which is one outcome, can be an event, or rolling an even number, which is more than one outcome, can also be an event. All right. The probability of an event, written as P and then parentheses the event that we're looking for, is the measure of how likely an event is to occur. Probability is a measure between 0 and 1 as shown on the number line. You can write probability as a fraction, a decimal, or a percent. And we looked at a little bit of this last week. So determine whether each event is impossible, unlikely, as likely as not, likely, or certain. So we think of this as likely as or not, that's like 50%, correct? So as likely as not, like is it going to rain? Well, it's as likely to rain as it's not to rain, 50%. So obviously, if you have less than 0.5 of a chance of something, it's either impossible or unlikely. And then more than 50% is going to be either likely or definitely certain it's going to happen. So rolling an odd number on a number cube. Well, there's 6 possible outcomes, right? And half of the numbers on a number cube are odd. So the probability would be 50%, which means that rolling an odd number is as likely as not. Determine whether each event is, same thing, same directions. What about rolling a number less than 2 on a number cube? Well, there's only one number less than 2 on a number cube, right? It's the number 1 out of 6 outcomes, 6 possible outcomes. So 1/6 is a very small fraction. So rolling a number less than 2 is unlikely to happen. It's not impossible, but it's unlikely. What about rolling a 3 or more on a number cube? Well, there are 4 numbers on a number cube that are the numbers 3 or more. Only 2 are not that, right? So out of 6 outcomes, we have 4 out of 6, which is greater than 50%. So it is likely. How about rolling a 2 or a 4? Well, there's only 2 numbers on a number cube that are 2 or 4, which is less than 50%. So rolling a 2 or 4 is unlikely. All right, what about these situations? Bonnie's Spanish club meets on Tuesday afternoon. So every Tuesday, Bonnie's in Spanish club. How likely is it that Bonnie is at the mall on Tuesday afternoon? Well, if she's at Spanish club, it's unlikely. It's not impossible. She could skip, but it's unlikely. What about there are 12 SUVs and 12 vans in a parking lot? How likely is it that the next vehicle to move is a van? Well, got a 50% chance, right? So it's as likely as not. Here we have a bag that holds 4 marbles that are red, 3 green marbles, and 3 yellow marbles, and 2 blue marbles. You pull one without looking. The probability of pulling a green is 1 out of 4. What is the probability of pulling a marble that is not green? Well, if the whole bag, if we're going to represent the whole bag with a fraction, one whole bag would be 4 out of 4. The probability of pulling out a green is 1 out of 4. That means the probability of pulling out a marble that's not green is 3 out of 4. 3 out of 4 is greater than 50%, so it's likely to happen. Tim never listens to his iPod during class. If he's in math class, how likely is it he's listening to his iPod? Well, he's not going to do it. It's impossible. He's already said he never does that, so it's impossible that he's going to do that. So a prediction is something that you can make, you can reasonably expect to happen in the future. Weather forecasters use several different methods of forecasting to make predictions about the weather. One way to make a prediction is to use probability. So based on Lawrence's experimental probability, what he has personally experienced, he reaches first base 40% of the time. Well, if he's at bat 350 times, how many times can he expect to reach first base? So he's going to take his probability, which is 40%, turn it into a decimal, 0.4, which is 4/10, and then we're going to multiply 4/10 times 350. So 4/10 times 350 is 140. So Lawrence can expect to reach first base 140 times out of 350 at-bats. You can also use the same information, set up a proportion, and you're going to cross multiply. Once you cross multiply, to solve for x, you're going to divide by 10. And then once again, we get 140. Lawrence can predict that he will reach first base about 140 out of 350 times. Mayla finds the experimental probability of her scoring a goal is 20%. So out of 225 attempts, how many times can she expect to score a goal? We're going to turn 20% into a decimal point 2, which is 2/10. And then we can multiply 2/10 times the total 225 and get 45. We could also set up a proportion. 2 out of 10 is 20%. We could cross multiply. Then to get x by itself, we're going to divide both sides by 10. And there we have 45 again. So Marla can predict that she will score about 45 goals out of 225 attempts. A spinner has 8 sections. 3 sections are labeled 1. In 50 spins, how often can you expect to spin a 1? Well, 3 sections out of 8, 3 out of 8, and then we would multiply 3 out of 8 times 50. We can set up a proportion, same thing. 3 out of 8 times 50 is about 18.75. So you would round that and say she can expect to spin a 1 about 19 times. About 19 times, right. The experimental probability of Mara shooting a goal in field hockey is 12% out of 300 shots. How many can Mara predict will be goals? And then number 2, if Scott flips 2 quarters 25 times, how many times can he expect to flip heads? Well, what'd you guys get? Number 1, we multiply 300 times 0.12. Number 2, what if Scott only flipped 1 quarter 25 times? So the probability of getting heads on a quarter is 1 out of 2, right? So if he did that 25 times, we would say half of 25 is about 12.5. But look, he's going to do it twice. He's going to flip 2 quarters. So we're going to actually multiply the probability 25 times each probability. So we're going to get 25 over 4. My pen's acting crazy. I don't know why it's doing those long lines. But 25 fourths is about 6 point something. 6 1/4, I believe it is. Yeah. Oh, that's messy. All right, this family is planning on going on a trip for 12 days. The region they have chosen gets the right conditions for skiing 46 days during a 62-day period. They want to spend at least 8 days skiing. So the first thing we want to do is to find the probability of getting the right conditions. Well, the experimental probability is 46 out of 62 days, right? I can simplify that, divide them both by 2, and I get 23. Oh, that's messy. 23 out of 31. And they're going to be gone for 12 days. They want to know if it's not going to snow 8 times. So 12 times 23 over 31, according to my calculator, is 8.9. So are they going to get to ski 8 days, at least 8 days? Yes, because according to the experimental probability, they're going to get to ski almost 9 days. There will be at least 8 days with the right conditions for skiing. All right. Katya finds the probability that the traffic light is red when she reaches an intersection. That happens 45% of the time. In 1 month, she goes through the intersection 65 times. How many times can she expect the light to be red? Well, 45% of 65 times 45% is 65 times 0.45 is about 29.25. So which of these is closest? So C is closest. All right, what about number 2? If you roll a number cube 12 times, about how many times do you expect to roll a number less than 5? Well, how many numbers on a number cube are less than 5? Well, 4 out of how many numbers? 4 out of 6. Well, that simplifies to 2 over 3, doesn't it? And we're going to do this experiment 12 times. So we're going to multiply straight across, and we get 24 out of 24 thirds, which is equal to about 8 times. Out of 12 experiments, we can expect to get a number less than 5, 8 times. All right, what's the probability of rolling a 5 or a 6 on a number cube? Well, there's 2 sides that are a 5 or a 6 out of 6, right? Which is 1/3. If you conduct 180 trials, predict the number of times the outcome will be a 5 or 6. So we're going to multiply 180 times 1/3. So multiply straight across. 180 over 3 is equal to 60. We expect that to happen about 60 times. What's the theoretical probability of rolling a 3 on a number cube? Ooh, that's good coffee. Well, there's only 1 3 on a number cube out of 6. If you roll the number cube 24 times, how many times should it land on a 3? Whoops, that should be a 6. So 24 6 is about 4 times, right? How many times? The answer is 4 times. So after rolling a 6-sided number cube 24 times, Sally rolled a 3 6 times. Do the theoretical and the experimental probabilities match? Nope, they don't match, because we got 4 out of 6, or did we? We got 4 out of 24, and they got 6 out of 24. The question is, by how much do they differ? Well, differ means to subtract. So 2 out of 24 from 6 out of 24 is 2 out of 24. They differ by 1/12. They differ by 1/12. What could Sally do to make them match more closely? Well, Sally could conduct more experiments. That's what Sally could do. All right, you guys, I think that's it. We're done with this little section. So now you guys are going to do the paper at the bottom. It's labeled E-50. When the boy tire maker married the girl tire maker, what did everyone say? I bet that's a very funny joke. Well, guess what? You're going to have to do some math to figure out what the punchline is. So when you're done with your problems, go ahead and send me a text entry and tell me what the punchline is. And then you can tell your dad or your mom, and they're going to laugh hysterically. That'd be fun. All right, guys, have a good day. See you later.